Hello everyone, welcome back to my channel. In this video, we are going to discuss some of the most asked interview questions on platform engineering. Let's start. Question number 1 is, what is platform engineering? So platform engineering is the practice of building internal tools and platforms that make the developers' lives easier. Instead of every development team figuring out infrastructure, deployment, security, monitoring, and cloud configurations on their own, a platform engineering team creates a self-service platform that developers can use to build and deploy applications quickly and safely. Now let's understand this with a simple example. Imagine a company has 100 developers. Without platform engineering, developers have to request the servers from the operations team. Then they have to manually configure the environments. They struggle with deployments, monitoring, and security settings, and every team does things very differently. But with platform engineering, the platform team creates a self-service portal. Developers only click a few buttons to create the environments. CI/CD pipelines are already available. Monitoring, logging, and security are already built in. Developers focus only on writing the code instead of managing the infrastructure. Now let us take a look at a real-life analogy. Think of platform engineering as building roads and highways. Developers are the drivers, applications are the cars, infrastructure is the city, and instead of every driver building their own road before driving, platform engineers build well-designed roads, traffic signals, and highways so everyone can travel quickly and safely. Now, why companies need it? Platform engineering helps the organizations in increasing the developer productivity, reduce the deployment time, improve the consistency, enhance the security and compliance, and reduce operational overhead and improve the developer experience. Now lastly, we have an interview winning answer, that is, platform engineering treats the internal developer tools as a product. The goal is to provide the developers with self-service capabilities for infrastructure, deployments, monitoring, and security so that they can focus on building the business features rather than managing the operational complexities. For example, instead of manually requesting the servers and configuring environments, developers can use an internal platform that automatically provisions resources and deploys the applications with built-in security and monitoring. The next question is, what is an internal developer platform? IDP. So an internal developer platform is a self-service platform built by platform engineers that helps the developers create, deploy, monitor, and manage applications without needing the deep knowledge of infrastructure, cloud, Kubernetes, or DevOps tools. Let us understand this with a simple example. Imagine you are a developer and want to deploy a new application. So the situation without an IDP would be you have to create the cloud resources manually, configure the Kubernetes, set up the CI/CD pipelines, configure the monitoring and logging, handle the security settings, and these may take days to complete all these tasks. Whereas with an IDP, you just have to log into an internal portal, click create application, fill in a few details. The platform automatically creates the infrastructure, configures the Kubernetes, sets up the CI/CD pipeline, enables monitoring, applies security policies, and the whole process may take only a few minutes instead of a few days. Now let us take a look at a real life analogy. Think of an internal developer platform like Amazon for developers. When you shop on Amazon, you don't need to know where the warehouse is. You don't need to arrange the transportation. You simply place an order. Similarly, developers using an IDP don't need to know the cloud configurations, don't need to understand the infrastructure details. They simply request what they need and the platform handles the entire complexity. Now, what an IDP usually provides? An IDP usually provides the following: self-service infrastructure provisioning, application deployment templates, CI/CD pipelines, monitoring and logging, security controls, Kubernetes abstractions, documentation, and developer portals. Coming to the next question, who builds the internal developer platform? So platform engineers build and maintain the internal developer platform while developers use it to build and deploy applications efficiently. We also have an interview winning answer. An internal developer platform is a self-service platform that abstracts the complexity of infrastructure, cloud, and operational tasks. It provides developers with standardized tools, automation, and workflows so they can focus on writing code and delivering the features instead of managing the infrastructure. Platform engineers build and maintain the platform while development teams consume it. Now coming to the next question, who are the customers of a platform engineering team? So the customers of a platform engineering team are the internal software development teams within an organization. So these are the internal team within an organization. Unlike traditional products that serve the external customers, platform engineering builds products and services for internal purpose and internal users only. Mainly their customers include DevOps engineers, software developers, QA and test engineers, SRE teams, data engineers, and application teams. Now let us understand this with an example. Suppose a company has 50 development teams. If every team has to configure the Kubernetes, create the CI/CD pipeline, set up the monitoring, manage the cloud resources, their productivity will decrease. So the platform engineering team builds an internal developer platform, IDP, the one that we discussed before, that provides these capabilities as a self-service tool. So platform team is the service provider and development team is the customer. We also have an interview friendly answer. So the customers of a platform engineering team are the internal engineering teams that build and operate the applications. Platform engineers treat these teams as their customers and provide them with self-service tools, automation, infrastructure, CI/CD pipelines, monitoring and security capabilities that improve developer productivity and reduce operational complexity. Now the next question is, how is the platform engineering different from DevOps? So DevOps is a culture and set of practices that encourage collaboration between development and operations team to deliver software faster, but platform engineering is a discipline that builds internal platforms and self-service tools that make the DevOps practices easier for developers to use. Let us understand with a simple example. First, let us take a look at the DevOps approach. So developers and operations team work together in DevOps. Teams create the CI/CD pipelines, monitoring and infrastructure. Each team may build and maintain its own tools. In case of a platform engineering approach, a dedicated platform team builds the reusable tools and platforms. Developers use these tools through self-service portals. Infrastructure, CI/CD, security and monitoring are all standardized. So in case of DevOps, it is both the teams working together. In case of platform engineering, it is not both the teams working together. So that's the main difference, that developers are involved in the DevOps approach, but here in platform engineering, developers are the customers who are using the self-service portals that are created by the platform engineering team. Let us take a look at a real life analogy. Imagine a city. DevOps is like teaching every driver how the roads, traffic signals and maintenance work so that they can travel efficiently. But in platform engineering is like a specialized team building the highways and roads so drivers can simply focus on reaching their destination. I hope this real life analogy explained to you the difference very clearly. Now here is the key difference in a tabular form on the screen. You can take a screenshot of this if you're preparing for any interview and refer this during a preparation. We also have an interview winning answer. So DevOps is the philosophy of improving collaboration, automation and software delivery between development and operations team. Platform engineering takes those DevOps principles and implements them through an internal developer platform that provides the self-service infrastructure, deployment pipelines, monitoring and security. So in short, DevOps is the philosophy, while platform engineering provides the product and tooling that enable that philosophy at scale. The next question is, what is self-service infrastructure? Self-service infrastructure means developers can provision and use infrastructure resources themselves without waiting for an operations or infrastructure team to manually create them. Let's take a look at an example. Imagine you are a developer and need a new testing environment. In the traditional way, you have to raise a ticket, you have to wait for the infrastructure team to respond. They will create the servers, databases and network configurations, and all these tasks, completing all these tasks may take a few days. But with self-service infrastructure, you just have to log in into an internal portal, click create test environment, select the required configurations. The infrastructure is automatically created in minutes and no manual intervention is required. Now let us take a look at a real life analogy. Think of self-service infrastructure like an ATM. Before ATMs, people had to visit a bank, request the cash from a teller. But with ATMs, people can get the cash themselves whenever needed. Similarly, without self-service infrastructure, developers depend on the infrastructure team. But with self-service infrastructure, developers can provision resources on demand. Some common resources that developers can provision on demand are virtual machines, Kubernetes clusters, databases, storage, development and test environments, load balancers, and cloud resources. Coming to why companies actually use it. So it helps in self-service infrastructure actually helps in faster application delivery, reduced waiting time, increased developer productivity, consistent infrastructure setup, and better automation. I have an interview winning answer for this question. So self-service infrastructure is a capability provided by a platform engineering team that allows the developers to provision and manage the infrastructure resources through automated tools, portals, or APIs without needing the manual assistance from the infrastructure team. This reduces the bottlenecks, improves the developer productivity, and accelerates the software delivery. Coming to the next question, what is developer experience or DevOps? So developer experience or DevOps refers to how easy, efficient, and enjoyable it is for the developers to build, test, and deploy and maintain the software. In simple terms, DevOps is for developers what user experience is for customers. Just as companies want customers to have a smooth experience using their products, platform engineering teams want developers to have a smooth experience building the software using their products that the platform engineering team has built. For example, imagine a developer wants to deploy an application. Poor developer experience would be, the situation would be like multiple manual steps, complex cloud configurations, long approval processes, difficult documentation, frequent deployment failures. The developer becomes frustrated and it's a waste of time. Whereas in case of a good developer experience, the situation would be like self-service platform, one-click deployments, clear documentation, automated CI/CD pipelines, built-in monitoring and security. The developer can focus on writing the code instead of dealing with all these infrastructure issues. Now let us take a look at a real-life analogy. Think of a restaurant kitchen. A chef can cook much faster if the ingredients are organized, equipment works properly, recipes are easy to find. If everything is messy, the chef spends more time searching and fixing the problems rather than cooking. Similarly, good DevOps helps the developers spend more time building features and less time dealing with the tools and processes. The next question is how platform engineering improves the DevOps. Platform engineering teams improve the developer experience by providing the internal developer platforms at the IDP, then self-service infrastructure, CI/CD pipeline, standardized environments, monitoring and logging, good documentation and automation. We also have an interview winning answer. So developer experience or DevOps is the overall experience developers have while building, testing, deploying and maintaining the software. It focuses on reducing the friction, increasing the productivity and making the development workflows easier through better tools, automation, documentation and self-service capabilities. Improving the DevOps is one of the primary goals of the platform engineering. The next question is, what is a platform product mindset? A platform product mindset means treating the internal platform as a product and the developers as the customers. Instead of just building tools, the platform engineering team focuses on solving developer problems and continuously improving their experience. For example, imagine the developers keep complaining that deploying applications takes 2 days. So without a product mindset, the platform team builds the tools they think are useful. Little feedback is collected, developers struggle to use the tools. But with the product mindset, the platform team talks to developers, understands their pain points, builds a self-service deployment platform, measures the adoption and satisfaction, continuously improves the platform based on feedback. Just like a company improves a product for its customers, the platform team improves the platform for the developers. Now let us take a look at a real-life analogy. think of Netflix. Netflix doesn't just launch a feature or forget it. They listen to users, analyze the usage data, improve the product continuously. A platform engineering team should do the same for developers. Now, the key principles of a platform product mindset includes: the developers are the customers, understand the customer needs, build solutions that solve the real problems, gather the feedback regularly, measure the adoption and satisfaction, continuously improve the platform. Now, let us understand why this mindset actually matters. Without a product mindset, developers may ignore the platform, teams may create their own tools, standards become inconsistent. But with a product mindset, higher platform adoption, better developer experience, faster software delivery, and reduced operational burden. We also have a interview winning answer. A platform product mindset means treating the internal developer platform as a product rather than just a collection of tools. The platform engineering team views the developers as customers, understands their needs, gathers the feedback, measures the platform adoption, and continuously improves the platform to deliver a better developer experience and increase the engineering productivity. The next question is, what is product adoption? So product adoption is the extent to which the users start using a product and continue using it regularly because it provides value to them. In platform engineering, product adoption means how many developers are actively using the internal developer platform as its service. For example, suppose a platform engineering team builds a self-service deployment platform. The company has 100 developers. Only 10 developers use the platform. This means low adoption. If after improvements, 80 developers start using the platform regularly, this means high adoption. So the platform is successfully solving the developer problems. Let us take a look at a real life analogy. Imagine a company launches a new mobile app. If people download it but never use it, adoption is low. If people use it every day, adoption is high. The same concept applies to the internal platforms. Now, why adoption matters in platform engineering? A platform is successful only if the developers actually use it. The platform team may build CI/CD pipelines, self-service infrastructure, monitoring tools, developer portals, but if the developers avoid them and create their own solutions, then the platform has failed regardless of how technically advanced it is. Now, how adoption can be measured? Examples of adoption metrics are: number of active developers using the platform, number of applications onboarded, number of deployments through the platform, reduction in manual support requests, developer satisfaction scores, percentage of teams using the platform services. We also have an interview winning answer. So product adoption refers to how successfully users embrace and regularly use a product. In platform engineering, it measures how many development teams are using the internal developer platform and whether it is delivering enough value to become their preferred way of building, deploying, and managing the applications or not. Now, how do platform engineers measure the success? Platform engineers measure success by how much they improve the developer productivity, developer experience, that's DevOps, and software delivery speed. Unlike application teams, platform engineering is usually not measured by revenue or customer sales. Instead, success is measured by the value delivered to the internal developers. Now, the key metrics in measuring the success. The first one is platform adoption. How many developers use the platform? How many applications are onboarded? For example, 90 out of 100 developers use the internal developer platform. This indicates strong adoption. And is developer satisfaction or DevOps. Are the developers happy using the platform? Do they find it easy to use? Measured through surveys, feedback forms, and developer interviews. What is time to provision the infrastructure? Before platform, creating an environment takes 3 days. After platform, creating an environment takes only 10 minutes. This shows clear improvement. Fourth is deployment frequency. How often can teams deploy the software? Higher deployment frequency usually means developers can deliver the features faster. The next is lead time for changes. How long does it take for the code to move from development to production? Reducing this time is a major goal. Is reliability of the platform, measured using availability or uptime, failed deployment rate, incident count, and mean time to recovery. Now let us take a look at a real life example. Suppose a platform team builds a self-service deployment platform. So before this, the situation was like environment setup would take 2 days, deployment process would take 1 hour, many manual approvals. But after this, the situation was like environment setup would take only 5 minutes, deployment would take only 5 minutes, fully automated. This is a successful platform because developers can move faster. Now we also have an interview winning answer. So platform engineers measure success through platform adoption, developer satisfaction, deployment efficiency, infrastructure provisioning speed, reliability, and overall developer productivity. The goal is to reduce the friction for developers and ensure them to deliver the software faster, more securely, and with less operational effort. The next question is, what is a golden path? So a golden path is a recommended, well-documented and easiest way for developers to build, deploy and operate applications using the organization's approved tools and practices. In platform engineering, the goal is don't force the developers to do things a certain way. Make the best way the easiest way. That easiest way is called the golden path. Understanding this with an example, suppose a developer wants to create a new microservice. Without a golden path, it will have to choose a programming framework, configure the CI/CD manually, set up the Kubernetes manifests, configure the monitoring, configure the security policies, and every team does things differently. The golden path, you will just have to click on create new service in the internal developer platform. A template automatically creates the application structure, CI/CD pipeline, monitoring setup, logging configuration, security controls, and the developer can start coding immediately. Now let us take a look at a real life analogy. Think of an airport. You could walk across the runway and find your own route to the gate, but the airport provides signs and designated paths that safely and efficiently guide everyone to the correct gate. That recommended route is the golden path. Understanding why golden paths are important. They help the organizations reduce the complexity, improve developer productivity, standardize best practices, increase the security compliance, reduce the support requests, speed up the onboarding of new developers. Take a look at a golden path example. A company may define golden path for a new application. Use the approved service template, use standard CI/CD pipeline, deploy to Kubernetes through the platform, use company approved monitoring, use standard security policies. Developers can still choose another approach if needed, but the golden path is the fastest and the most supported option. We also have an interview winning answer. A golden path is a curated and recommended developer workflow that provides the easiest and the most efficient way to build, deploy, and operate applications using approved tools, templates, and best practices. Platform engineering teams create golden paths to reduce the complexity, improve the developer experience, and ensure the consistency across the organization. The next question is, what is platform standardization? Platform standardization is the practice of providing a common set of tools, processes, templates, and technologies that all the development teams use across the organization. Instead of every team doing things differently, platform engineering creates standard ways of building, deploying, monitoring, and securing the applications. For example, imagine 10 development teams. Without the standardization, the situation would be like Team A uses Jenkins, Team B uses GitHub Actions, Team C uses GitLab CI, Team D uses a different monitoring tool, Team E deploys applications differently. This creates complexity and supports challenges. But with a platform standardization, all teams use the approved CI/CD pipelines, all teams use the same monitoring solution, all teams follow the same security standards, all teams use the common deployment templates. This makes the operations much simpler. Let's take a look at a real life analogy. Think of driving a car. Imagine every car manufacturer puts the brake pedal in a different location, the steering wheel on a different side, the accelerator in a different place. Then driving would become really confusing, right? Because cars are standardized, people can drive almost any car without relearning everything. Platform standardization does the same thing for the developers. Now, what gets standardized? So some common examples include CI/CD pipelines, Kubernetes deployment templates, logging and monitoring, security controls, infrastructure provisioning, application templates, development environments, all these usually get standardized. Let's discuss what are the benefits. The benefits would include faster developer onboarding, reduced operational complexity, improved security and compliance, easier troubleshooting, better developer experience, and lower maintenance costs. Also have an interview winning answer. So platform standardization is the process of establishing and promoting consistent tools, workflows, templates, best practices across the engineering teams. Platform engineering teams use the standardization to reduce the complexity, improve reliability, strengthen security, and enable the developers to deliver software more efficiently while maintaining the organizational consistency. Now, what is platform scalability? Platform scalability is the ability of a platform to support a growing number of developers, applications, and workloads without a significant drop in the performance, reliability, or user experience. In simple terms, as the company grows, the platform should grow with it. For example, suppose a company starts with 20 developers, 10 applications, the platform works perfectly. A year later, the company has 500 developers, 200 applications, thousands of deployments per day. So if the platform continues to work efficiently without becoming a bottleneck, it is scalable. Now let us take a look at a real life analogy. Think of a road. So a small road may work well for 20 cars, but if 2000 cars start using it, traffic jams occur. A scalable highway is designed to handle increasing traffic without major delays. Similarly, a scalable platform can handle increasing numbers of users and workloads. Platform engineering, a scalable platform should be able to support more developers, more applications, more deployments, more cloud resources, more environments, more teams without requiring a proportional increase in manual work. Signs of a non-scalable platforms are: developers wait for infrastructure teams, manual approvals increase, deployments become slow, platform outages increase, support tickets grow rapidly. Coming to how platform engineers achieve scalability, they use automation, self-service infrastructure as code, standardized templates, Kubernetes and cloud native technologies, reusable platform components. An interview winning answer would be: platform scalability is the ability of a platform to efficiently support increasing numbers of developers, applications, and workloads while maintaining performance, reliability, and developer experience. Platform engineers achieve scalability through automation, standardization, self-service capabilities, and cloud-native architectures, ensuring that the platform can grow alongside the organization. Now, what is platform reliability? Platform reliability is the ability of a platform to consistently perform its functions correctly and remain available when developers need it. In simple terms, developers should be able to depend on the platform at any time without frequent failures, outages, or disruptions. Now let us take a look at a real life analogy. Think of electricity in your home. You expect electricity to be available whenever you switch on a light. If power goes out several times a day, the service is unreliable. Similarly, developers expect the platform to work whenever they need it. Now, why reliability matters? If the platform is unreliable, developers lose productivity, releases are delayed, support tickets increase, trust in the platform decreases, teams start creating their own solutions. How platform engineers improve reliability? Because they use monitoring and alerting, automated testing, high availability architectures, backup and disaster recovery, redundancy, incident management practices, and capacity planning. Coming to what are the common reliability metrics, platform teams often measure availability or uptime, mean time to recovery (MTTR), incident frequency, error rates, deployment success rate. An interview winning answer could be: platform reliability is the ability of a platform to consistently deliver its services with minimal downtime, failures, or performance degradation. It ensures that developers can confidently rely on the platform for application deployment, infrastructure provisioning, and operational tasks. Platform engineers improve reliability through monitoring, automation, redundancy, and proactive incident management. Next question is: what role does automation play in platform engineering? So automation is one of the most important aspects of platform engineering. It reduces manual work, eliminates the repetitive tasks, improves the consistency, and allows developers to move faster. Without automation, developers and operations teams spend a lot of time performing the repetitive activities. With automation, these tasks happen automatically and consistently. For example, suppose a developer needs a new test environment. Without automation, he would have to raise a ticket, wait for the infrastructure team, then create servers manually, configure the networking and permissions. Environment becomes available after a few days. But with automation, developer clicks the create environment, the platform automatically provisions everything, environment is ready in minutes. This is automation in action. Now let us discuss what platform engineers actually automate. So the common examples include infrastructure provisioning, application deployment, CI/CD pipelines, Kubernetes configurations, security policy enforcement, monitoring and alert setup, environment creation, backup and recovery processes. Let us take a look at a real life analogy. So thinking of a washing machine. Without it, you wash clothes manually every time. With a washing machine, the repetitive work is automated, saving time, reducing effort. So platform engineering does the same for software delivery tasks. Benefits of automation would include faster software delivery, reduced human errors, improved consistency, better scalability, higher reliability, improved developer experience, and less operational overhead. Example in a platform engineering environment is a developer wants to deploy a microservice. The platform automatically builds the code, runs the tests, creates the containers, deploys to Kubernetes, configures the monitoring, and applies security policies. The developer focuses on writing the code while the platform handles the operational work. An interview-winning answer would be automation is a foundational principle of platform engineering. It enables self-service capabilities by automating infrastructure provisioning, deployments, security controls, monitoring, and operational workflows. By reducing manual effort and standardizing processes, automation improves developer productivity, scalability, reliability, and overall developer experience. Next question is, what is platform governance? Platform governance is a set of rules, policies, standards, and controls that ensure the platform is used securely, consistently, and in compliance with organizational requirements. In simple terms, governance ensures developers have freedom to move fast, but within safe and approved boundaries. For example, suppose developers can create cloud resources through self-service platform. Without governance, anyone can create any type of resource. Security settings may be inconsistent. Costs may increase uncontrollably. Compliance requirements may be violated. But with governance, only approved resource types can be created. Security policies are automatically applied. Cost limits are enforced. Compliance requirements are built into the platform. Developers can still work quickly but safely. Now let us take a look at a real life analogy. Think of driving a car. Drivers have the freedom to travel wherever they want. However, they must follow the traffic signals, speed limits, road rules. These rules are governance. Similarly, platform governance provides the guidelines and controls for using the platform. Now, what platform governance actually include? So security policies, access controls and permissions, compliance requirements, infrastructure standards, resource usage policies, cost management controls, deployment approval processes, audit and reporting mechanisms. All these are included in platform governance. Now coming to why governance matters. So without governance, security risk increases, compliance violations occur, cloud costs grow unexpectedly, teams use inconsistent practices. But with governance, it is better security, better compliance, controlled costs, consistent operations, and reduced risk. The platform engineering approaches. Modern platform engineering aims for governance through automation, not manual approvals. For example, security policies are automatically enforced. Infrastructure templates already meet the compliance requirements. Approved configurations are built into the platform. This allows the developers to move fast without sacrificing the control. An interview-winning answer would be platform governance is the framework of policies, standards, and automated controls that ensure the platform operates securely, consistently, and in compliance with organizational requirements. It balances developer autonomy with necessary security, compliance, and operational safeguards while enabling teams to deliver the software efficiently. Next question is, why is documentation important in platform engineering? So documentation is important in platform engineering because it helps the developers understand, adopt, and effectively use the platform without constantly needing the support from the platform team. So a great platform is only useful if the developers know how to use it. For example, imagine a platform team creates a self-service deployment portal, automated CI/CD pipelines, infrastructure provisioning tools. But without documentation, developers don't know how to use them. They raise the support tickets, they make mistakes, platform adoption remains slow. But with good documentation, developers can onboard quickly, they can solve the common problems themselves, they use the platform correctly, and support requests decrease. Taking a look at a real life analogy, think of buying a new smartphone. Even if the phone has amazing features, many people won't use them because they do not know how to use it. So there is a guide explaining how they work. Similarly, documentation acts as the user guide for the platform. Coming to what should be documented, platform documentation typically includes getting started guides, application deployment guides, self-service infrastructure instructions, CI/CD pipeline usage, troubleshooting guides, security best practices, platform standards and policies, FAQs, and common issues. Why documentation matters? It improves developer experience, increases the platform adoption, reduces the support tickets, speeds up the onboarding, and ensures consistency. Coming to platform engineering perspective, so a platform should be treated like a product. Just as customer facing products need documentation, internal developer platforms need user guides, tutorials, for example, best practices. A good documentation is a critical part of delivering a good developer experience. An interview winning answer would be documentation is essential in platform engineering because it enables developers to understand and effectively use platform capabilities without relying heavily on the platform team. High quality documentation improves the developer experience, accelerates the onboarding, increases the platform adoption, reduces the support overhead, and ensures consistent use of platform standards and best practices. Next question is, what are some of the common tools used in platform engineering? So platform engineering uses tools for infrastructure automation, container orchestration, CI/CD, monitoring, security, and developer self-service. So these tools help the developers build, deploy, and manage applications more efficiently. So common platform engineering tools are container orchestration, used to deploy and manage containers, Kubernetes, and OpenShift. The purpose of this is to run and manage the applications at scale. Next is infrastructure as code, which is used to automate the infrastructure creation, Terraform and Pulumi. Purpose of this is to create the servers, networks, databases, and cloud resources automatically. Third is CI/CD tools used to automate build, test, and deployment processes. These are Jenkins, GitHub Actions, GitLab CI/CD, and Argo CD. The purpose is to automate the software delivery. Then we have source code management, which is used to store and manage the code like Git, GitHub, GitLab, Bitbucket. The purpose is version control and collaboration. Then we have monitoring and observability, used to monitor platform health and application performance like Prometheus, Grafana, Datadog. Purpose is to detect the issues and monitor the performance. Then we have logging tools which are used to collect and analyze the logs like Elasticsearch, Kibana, Splunk. The purpose is troubleshooting and operational visibility. The next is developer portal or internal developer platform, used to provide self-service capabilities like Backstage. Purpose is central place for developers to access services, documentation, and templates. And next we have cloud platforms, so infrastructure hosting platforms like Amazon Web Services, Microsoft Azure, and Google Cloud. Purpose is to provide compute, storage, networking, and managed services.